So this video is on solving radical equations. So we'll start with an example. Square root of x minus 1 equals 3. And when you're solving a radical equation, there's only one new thing that we're really doing here. We need to eliminate the radical, the square root sign from that side of the equation, because we can't do anything with the inside until we've dealt with the radical. So what's the opposite of a square root? And of course, I'm going to square both sides. So if I square the entire radical, and I square the right side of the equation, if I square a square root, I'm just left with what's inside. So I'm going to have x minus 1, and 3 squared is 9. Then I add 1 to both sides, and x equals 10. So this first one, obviously very easy. With radical equations, it's really important to get in the habit of checking this answer. So I'm going to check by plugging it back in. Square root of 10 minus 1, does it equal 3? 10 minus 1 is 9, and we know the square root of 9 is 3, so that works. In general, there's really only a few things you do when you're solving a radical equation. You want to isolate the radical as much as possible. There's sometimes you can't completely isolate it, but you can get close. You'll square both sides. And then you'll solve, because at that point you will no longer have a radical. So solve using previous knowledge. So let's look at a second example. The square root of 2x minus 6 equals square root of 3x minus 14. Forgot a very important last step here. Check all answers. Right? So, we're solving this equation. Square root of 2x minus 6 equals the square root of 3x minus 15. Now, the first thing we want to do is isolate radicals. Are they isolated? Are they on one side by themselves? And they are, so we can just go ahead and square both sides right off the bat. Now again, if I square a square root sign, all that happens is the two operations cancel out, right? So I'm left with whatever was inside of those square root signs. So I have 2x minus 6 equals 3x minus 14. At this point, solve using previous knowledge. We know how to solve this. You've been doing that for 5 years now or something. So I think the easiest way to do this, subtract 2x from both sides and add 14 to both sides. And we'll get 8 equals x. Remember, last step, check your answer. So, off to the side here. The square root of 2 times 8 minus 6, does this equal the square root of 3 times 8 minus 14? 2 times 8 is, what did I do here? That's minus 6, I apologize. 2 times 8 minus 6. So 2 times 8 is 16, and 16 minus 6 is 10. Square root of 10. 3 times 8 is 24, and these 24 minus 14 is also 10. So the square root of 10 does equal the square root of 10. Okay, let's do a slightly more complex example before jumping into a real complex example. So the square root of x plus 4 equals 2 times the square root x minus 2. Now, we want to isolate the radical, and we have this 2 in front. Unfortunately, there isn't a lot we can do, because if we divided this side by 2, we would divide the other side by 2, and we'd still have that 2 just in a different place. But we can still square both sides. This is why I wrote as much as possible. We can still square both sides, as long as you remember to square the whole side, right? So, this one is standard. These two cancel out. Now, here we have 2 times the square root of x minus 2 squared. So we have to square each part. So 2 squared is 4, and x minus 2 squared is x minus 2. Now we can solve this like a normal equation. So we would distribute the 4. We have x plus 4 equals 4x minus 8. And I'm going to subtract a 1x from both sides and add 8 to both sides. So I have 12 equals 3x, and I divide by 3. So I should get x equals 4. But I'm not done until I check it. So does the square root of 4 plus 4 equal 2 times the square root of 4 minus 2? This is square root of 8, and this is 2 times the square root of 2. And remember, the square root of 8 simplifies into square root of 4 times the square root of 2, which is 2 root 2. So they are the same. 2 root 2 equals 2 root 2, or square root of 8 equals 2 root 2. Yet another reason why it's important to know how to simplify radicals when they're in this form, so that you can check your answer and not just assume that these are not equal because they don't look the same. All right. Now, let's do a much more complex example. We have x minus 6 equals square root of x.
Can we please have Ashley Rodarte, Madison Faye, Nayeli Bautista, Salma Espinosa, Brittany Travis, Angelica Salazar,
I better
Eric
be all.
Carter, Alexis Prosser, Key Matsumoto, and Zabiel to the Media Center. Thank you.
So we do have a radical isolated, so we're going to go ahead and square both sides. So square root of x squared. But when I say square both sides, I mean the entire thing. You can't just square terms individually. I know you want to, I know it looks easier, but you have to square the entire thing. So the square root of x squared is just x. And then here I have to multiply the whole thing out. So this is x minus 6 times x minus 6, which of course multiplies out to x squared minus 12x plus 36 equals x. Now, you're not done because you isolated x. You can't just say x equals some other things with x in it. Solve using previous knowledge. Well, what type of equation do we have here? I know y'all just yelled at your screen. You said quadratic all together. I could hear you. So, we have a quadratic, which means we need to set this equal to 0 in order to solve it. So I'm going to subtract my 1x off of both sides. So now I have x squared minus 13x plus 36 equals 0. At this point, I could solve using the quadratic formula or factoring. I do believe this equation is factorable. Can I find two numbers that multiply to have a product of 36 and a sum of negative 13? And negative 9 and negative 4 are going to work. Negative 9 times negative 4 is 36. Negative 9 plus negative 4 is negative 13. So this factors to x minus 9 times x minus 4 equals 0. Which means my two solutions are x equals 9 and x equals 4. But I'm not done. I have to check. So I have two possible solutions here. Something weird is going to happen when I check, I promise. So we have to check using our original equation. The first one we have is 9 minus 6 equals square root of 9. We're plugging in 9 for all of the x's. So 3 equals the square root of 9. That works. The other one, 4 minus 6 equals the square root of 4. Negative 2 equals the square root of 4. And this one ends up not working because, now I know you're thinking 4 does have two square roots, but this equation implies only positive square roots. If we wanted negative square roots, then we would specify that, or if we wanted both, we would specify and it would say plus or minus. But this does not have a plus or minus, so it's only the positive square roots. So the square root of 4 equals 2, and not the positive square root of 4 equals 2. So this one doesn't work. We had a solution to our problem that ended up not working in our original equation. So this is what's called an extraneous solution. An extraneous solution is when extraneous solution is a solution that emerges from the process of solving a problem but is not a valid solution to the original equation. So in that last problem, x equals 4 was an extraneous solution. It came about by the method of squaring both sides. Sometimes that can introduce extraneous solutions to a problem. We'll do one last problem here. Say we have the square root of 7x minus 10 equals x. So, do we have a radical isolated? We do. So we can go ahead and square both sides. And this one was nicer because the radical cancels here, so we have 7x minus 10 equals x squared. Now, again, we're dealing with a quadratic equation, so we know with quadratics we have to set them equal to 0. So I'm going to subtract 7x and add 10 to both sides. Now I have 0 equals x squared minus 7x plus 10. Also, this can be solved by factoring. I have a product of 10, sum of negative 7, that's going to be negative 5 and negative 2, right? So 0 equals x minus 5 times x minus 2 means I have 2 possible solutions. Still, I have to check all of my answers. So, square root of 7 times 5 minus 10, does that equal 5? So here I'm checking x equals 5, so I plug in 5 for all of the x's. This is 35 minus 10, so square root of 25 equals 5. That works. And the other one, 7 times 2 minus 10, does that equal 2? 7 times 2 is 14, 14 minus 10 is 4, square root of 4 is 2. So, always check both solutions. You can have sometimes where there's no solution, sometimes where you have multiple solutions, sometimes where you have one extraneous. So you always have to check both. We will talk more about extraneous solutions in the next class because I know they can be a little bit weird to deal with. But for now, that is the end of the workshop.